Welcome to Study Loop.
This is problem 117 of chapter 7.4 of Vector Mechanics for Engineers, Statics, and Dynamics. So in this problem, there is a cable running from A to B, and it has a length of 1,100 feet, and the vertical distance from A to B is 496 feet, and the slag in the cable is 30 feet. And there are also vertical cables going down from the main cable, and it can be treated as a distributed load, and it's 10.2 kip per foot. So the purpose for this problem for A is to determine the max tension in the main cable and determine the slope of the cable at B. So the first thing we're going to do is to determine the weight of the cables in the vertical direction that we can treat as a distributed load. So this will be 10.2 times the length, which is 1,100 feet. And this equals 11,220 kips. So we're going to draw the free body diagram from A to B. We're going to include the reaction forces at B. So Bx will be drawn in the positive x direction, and By is in the positive y direction. And also the reaction forces at A. Ay is in the negative y direction, and Ax is in the negative x direction. So we're going to do the sum of moments around A and set that equal to 0. And this equals By times 1,100 feet, because there's 1,100 feet in the horizontal direction between A and B, minus Bx times 496, because there's 496 feet in the vertical direction between A and B, minus the load times 550, because there's 550 feet between the load in the middle of the cable to B in the horizontal direction. So I'm going to go ahead and simplify. So 1,100 By minus 496 Bx equals 6,171,000. I'm going to go ahead and solve for By. By equals 5,610 plus 496 over 1,100 Bx. We're going to need this equation later on. Now we're going to draw a free body diagram from the middle of the cable, which I'm going to call O, to Bx, or just B. So we're going to do the sum of moments around O, set that equal to 0. So this equals By times 550 feet, because there's 550 feet in the horizontal direction between O and B, minus Bx times 278, because there is 248 is half the vertical height from A to B, and then plus 30 because that is the slag in the cable. We're going to subtract the load divided by 2, because we're only dealing with half the cable, times 550 divided by 2, because that is the horizontal distance between the load at the middle of the cable and O. So we're going to go ahead and substitute this By that we solved up here, down here, so we can solve for the Bx. So it's 550 times 5,610 plus 496 over 1,100 Bx minus 278 Bx. I'm going to go ahead and move this load to the other side. And it is 1,542,750. And we can go ahead and solve for Bx completely. It's 51,425 kips. Okay, now we can also solve for By, because we know the equation is 5,610 plus 496 over 1,100 Bx. Plugging in Bx, which we just solved for, we obtain 28,798 kips for By. Alright, now that we have both the components at B, we can solve for the slope at B, which is the inverse tangent of By over Bx. Make sure your calculator is in degrees when solving for this. It is 29.25 degrees, which is the answer for part B of this problem. Now we can solve for the max tension as well. Is the square root of Bx squared plus By squared and this equals 58,939.4 kips. And this is the solution for part A of this problem, the max tension in the cable.